Okay, everybody. Few announcements, and then we'll jump into our lesson today. Today's lesson actually doesn't take super long, which should give us a good amount of time to work on things actually at the end of class. Kind of your things on your to-do list should be number 1, corrections for Unit 3 tests. Those are due tomorrow at 10 p.m. Okay, I don't set it for midnight because I don't want to encourage you to stay up till then, even though it's the weekend. Okay, because I know if I set it for that, then a lot of you will wait till then. Okay, reminder that there's no retake. You just have to submit your corrections. I'll look over them and you'll get points back. If by chance I look over your corrections and feel like you're not quite understanding, then before I put your points in, we'll have a conversation to make sure you understand. Okay, but as long as you do them to the best of your effort, you should get all the points back. Okay. If by chance there was a student who very wisely asked to still retake the test just to practice, because obviously this stuff is carrying through, I will make that available for anyone who wants it. It's not required in any way whatsoever, but if you want to do it over Christmas or something like that, I'll figure out how I'll do it, or maybe I'll just give you a paper copy. You could still retake it just to kind of test yourself to make sure. Because once again, Unit 3 is weighted a little heavier than the other units on the AP exam. So we want to make sure we're understanding that. Other things on your to-do list is the precipitation lab is due tonight. So if you haven't finished and submitted that, I would get that done first. You started it in class, so should be at least not from nothing, right? And then the silver lab, which was part of your homework last time. Looks like some of you have done that. Hopefully, is there anyone who's done it all the way that can maybe say like how long it took them? Just to give others an idea.
I just saw the video.
Oh, it took me 8 hours.
Nuh-uh.
No, actually.
I was like, no, wait, Bryce. Don't scare them. Have you seen Evan's eyes?
I was up all night. So have fun, guys. It's not.
It's like the video's 20 minutes, but half the video is I walk you through the entire pre-lab. So literally, I do half the questions for you if you just watch the video. And then the other half of the video is you've seen what happens in the lab, and then you just got to do like, I think there's like 5 post questions, and that's it. That's due next Wednesday, so you do still have time for that. But just because it's the end of the term, and I want everyone to be aware of where your grade is going to be, this weekend, if it hasn't been turned in, I am going to just put in zeros. Maybe just to motivate some of you, like, hey, if you don't end up doing this, this is where your grade will stay. I just don't want your grade flipping on you 3 days before the end of the term. But it won't be marked late. You'll still have till Wednesday to turn it in. Okay? Any other questions about end of term stuff? Yes, Bailey.
Have you graded the Unit 3 makeup points?
No, I will grade those. So normally I wait. I think they're due tomorrow.
Yes.
On Canvas it said they were due on like Monday.
Or maybe they've already been.
No, I thought they were due.
Yeah, they were due the other day, and I think the precipitation lab
You
said it was due
told us
tomorrow.
that they would be due tomorrow, but then on Canvas it said they were due like Monday night.
Is it still open till tomorrow?
I don't know.
Oh. Maybe I
It's
missed
still
it.
open, but I don't know.
As long as it's still open, I don't do late points for this.
Oh, I need to do that.
Pretty
I thought
much.
they closed on Monday, so I was kind of stressed. We're good.
Normally, I'll grade those once it closes, because that's when it pops up on my screen. So probably this weekend I'll put those bonus points in so you can kind of see how that affects your grade too. So, any other questions about things? And I guess if I put the precipitation lab till tomorrow, you luck out, because I'm not going to change it.
Sick.
I thought it was due today, but I can't keep track of any dates, I guess. So,
That's okay.
I guess if I can't keep track in extending things, it's in your Okay, turn to page 9 for me, everybody. Let's talk about these types of reactions.
My goal is to not be, especially science, I really don't want to. Last term, like 14%. Wait, like not do anything. How
But
does
then
that be
solar
like?
water evaporates.
That's why if you like, if your microwave at the end of a plate of food, you put less water in it, it just makes it like less. It just makes it better.
That's so cool. Yeah, I saw that in like one of those stupid
Yeah,
life hack videos. I was like, what? Something useful? That's actually
It might be like.
I know.
Now, all of you need to teach the rest of the students how to appropriately email a teacher. You guys are all great whenever you email us. Some other kids need some help. This email like literally just says, put in my word. I'm gonna buy that computer.
Like, you should just put an email me properly and then I
Like,
will.
try asking, like, it's like my 2-year-old, like, when she's like demands things like this, Emily asked for something. Is that how I need to say it to her? Like, I'll do it for you, but you could ask me nicely, especially your little turned it in 3 weeks late. Okay, here we go. Alright, so the last part of Unit 4, so we just have today and Tuesday, and then we're done with Unit 4. Just a reminder, you're going to take the test for it before Christmas break.
Wait,
I'm looking at some of you.
what? Wait, is that? All of it said it.
I totally forgot about that.
Okay, but it's not going on this term. It's going on next term.
There's still.
Yeah, our math teacher is
I don't
giving us
feel like I'm ready for this
on
test.
Monday, and it goes on this term.
Yeah.
What?
What?
Oh, we took a
I guess
test
you have a-
today and it's going on this. Yeah, I know, dude. That
If I don't do
was
good on it,
ridiculous.
I'm gonna have to retake 3 tests on Thursday and Friday.
I'm pretty sure.
All for math.
All
I thought I did a
Wait, why 3 for 1 test?
Oh, it's all like different
Oh,
tests.
you
and like,
can't do
goals.
any retakes till the end? Oh, wow. Good luck with that.
Yeah. It's not great.
But I want you all to take it before so you don't have to forget things and right, so on and so forth. Okay? Alright, so what we're learning today is about another type of a reaction. So we've already talked about one type, precipitation reactions. Let's just review those really quick. Okay? A precipitation reaction is the ones like our lab where you mix 2 aqueous things together and it turns into an insoluble product, right? In terms of our eyes, how we know it's a precipitation reaction is because we would see a precipitant form.
Yes.
At the molecular level, what we would see is, right, that insoluble product. So we're going to see in the reaction a solid on the product side. And on the reactant side is where you should see the aqueous. So one thing you should be able to do in this unit after we've learned our lesson today next time is if I show you a reaction, just like all the symbols, you should be able to say, oh, that's a precipitation reaction, or oh, that's an acid-base reaction, labeling them based off our patterns, okay? Now for the other 2 types we're learning today and next time, we will have entire units designated to these types of reactions. So for now, we just want to understand their patterns and how to identify them. But in case you're kind of like have more questions, especially as you do the reading on it, there's a whole unit about redox and there's a whole unit about acid and base coming up, okay? Particularly, we'll see a lot more like the lab application side. So another type, this is the one we'll talk about on Tuesday, are acid-base reactions. Landon, did I hit play on that?
Yeah.
Okay.
I always like have them pause like, what is that? Okay, acid-base reactions, the way we define them is it's a transfer of a proton. Now the reason why I put proton in quotation marks is it's really what we're talking about here is an H+ ion. Now turn to your table, buddy, and have a quick discussion. Why would chemists call an H+ ion a proton? Ready, go.
There's no
There's no electrons.
So it would just be like.
It's pretty much a proton.
Yeah.
Well, I mean, it's like.
Well,
Okay, I think I heard the answer in various formats, but the basic idea, right, is hydrogen only has 1 proton. +1 charge, it means it's lost an electron. It only has 1 to begin with, and so you're kind of left with just a proton. Now, why we do quotation marks is what else is there possibly? Neutrons, right? Depending on the isotope, it has neutrons as well. But that's kind of the nickname we give it dealing with acids and bases. So acids are what we call proton donors. So if something that we label an acid is a proton donor because it gives up its proton, bases on the other side are proton acceptors.
They just take handouts.
Now the arrow looks a little weird if you look at this, because a lot of people would look at this and look like, oh, something's moving over there.
Yes, that is why there's an arrow on the end of the line.
What in the way I think about it is it's more like the arrow is the negative charge here is grabbing a positive charge and bringing it over here.
That is a poorly drawn.
Yeah, why can't they put the arrow the other way?
Yeah.
I
but
know,
arrow
it's
should be
not
going the
my
other way.
preferred way of doing it. I've seen it both ways, this image that I saw just did it this way. But that's why the H is now over here, is because the base has accepted it and the acid has lost it. That's what we'll do on Tuesdays, we'll practice tracking the movement of protons, okay? Our third type of reaction, which we're focused on today, are known as oxidation reduction reactions. Or abbreviated, we call them redox for reduction and oxidation. These reactions are all about the transfer of electrons. Something is losing and something is gaining. By definition, electrons are transferred from the thing that is oxidized to the species that is reduced. So oxidation means to lose electrons, reduction means to gain electrons. Now there's some little silly like mnemonic phrases or like ways to help you remember their definitions if you like that kind of thing. In college I learned the phrase oil rig. Okay, where oxidation is losing and reduction is gaining.
Of course, oil rig.
So honestly, whenever I took a redox test, I would write oil rig on top of my test just to make sure I keep it straight. Because at first thought, the word reduction feels a little backwards. What does it generally mean if I say something has been reduced?
To take away.
Take away. So turn to your table, buddy, and let's figure out why would chemists call reduction in this sense a gain? Or
Because it's a
ready, set, go.
I would say because
Because
it's losing the positivities but becoming more negative.
Yeah. So it's
Losing its charge.
yeah.
Yes, you're
Gaining. Why did I write oxidize?
You can make a little triangle and hide it when we discuss. Or a liquid.
Every time I
Now I made it
write
all
You totally won't be offended if you choose that.
Okay, I heard us all say it, but it's that idea of like the negatives, right? That the
Yeah.
thing we're gaining are negatives, and if you gain a negative, you become more negative. Okay? So simple redox reaction here. Lithium gives its electron to fluorine, which means it's being oxidized. Fluorine has been reduced. Oxidation reduction. Okay? Now our goal by the end for our homework assignment is to be able to identify in a chemical reaction what's being oxidized and what's being reduced. Now in terms of these ones, it's pretty straightforward. What gets tricky is sometimes the electrons are more hidden, and that it's hard to see where they're traveling to. Okay, so let's get a little bit more detailed and then more out of that. Okay, this is another example of a redox reaction. This top one, if you want to label it, this is the overall. And this has been simplified down to the net ionic reaction. For smiley face, don't say it out loud. Can you tell me what was my spectator ion that got removed? Don't say it out loud, just raise your hand if you can tell me. What's the spectator ion in this reaction? And on the count of three, shout it out. 1, 2, 3.
Nitrate.
Very good. You said nitrate, have a smile.
Wait, that's nitrate.
Yeah, I said I know 3, so I guess I'm on right.
You can have a smile face.
I just realized we still have the 20.
I'll add those. Okay, so now everybody, come back up front here. What we want to do is we want to identify in this reaction what's being oxidized and what's being reduced. So the way we can do that is by tracking the movement of charges. Okay? So in the net ionic equation, copper right here is all by itself, which means it has 0, it doesn't have a charge. I see on the product side that its charge is now +2. So if you've gone from a 0 to a +2, has it lost or gained
Sounds good.
So loss means oxidation.
Oh yeah, you were making, that was a good joke right there.
Thank you, guys.
That was funny.
Thank you.
So we would say that copper is being oxidized. Silver's going from +1 to 0. So it's being reduced.
Wow.
Side note, if you haven't or you have already, this is the reaction that I did in the lab video, where I took solid copper wire, I drop it in a beaker of silver nitrate, it's a solution
It cost
aqueous,
like $40.
okay? The copper nitrate, or the copper not dissolves, but it reacts with the nitrate and goes into the solution, and the silver comes out of the solution as pure silver. So for those that, I guess when you watch it or if you haven't yet, or if you have, here's the silver that I made.
What is that
Wait,
word?
yeah, can you sell that?
So yeah, we could sell it. It looks weird just because it forms in like flakes. Is it worth more?
Wait, so can you just like make gold?
So if I were to steal that.
That's kind of the catch, right? Is technically to make this, what did I buy?
Oh, more expensive.
Silver nitrate, which is pretty expensive. I guess I didn't buy it, the school did.
Yeah.
So
you got it.
So look at it that way. But kind of cool to see.
Wow,
do what you gotta do.
I just need to find a blowtorch and I can melt it down, make something out of it.
We should do that.
He also has a guitar.
I gotta look, I just got a blowtorch melt silver. How hot does it get?
A propane torch gets up to 3,000. We were
Does it?
looking it up the other day. Well, depending on your propane torch. Because we were trying to melt it.
This is
Which burns at it.
Okay, well maybe. I just always thought it'd be cool to like melt it into something, because then it would look even, right now it kind of looks just like
Which is
sparkly
only like
dust.
You could make a mold.
Yeah, like melt it into something cool. I don't know. But
yeah, no,
anyway,
you should make a ring and then we can just like do all fight over it.
like the class, like Lord of the Rings.
Yeah,
Oh,
exactly.
Maybe like the class ring, like whoever scores the highest gets to wear it, and then it has
Oh, yes.
Whoever scores the highest around their neck on a necklace, right?
Yeah, until the next test.
Frodo.
Okay, so for a half reaction, we just pull out those pieces. Okay, come back up front here, everybody. So solid copper is changed into a copper ion. Now the half reactions are going to show those electrons. So the electrons are being lost, so we put them on the product side of the arrow. Or in a sense, it has to be balanced, right? +2, -2 is what gives me the 0. For the reduction half reaction, we have 2 Ag pluses. Now they're gaining the electrons, so they need to go on the left side of the arrow to make our solid silver.
Of course.
So the location of the electrons is very critical in identifying oxidation and reduction. And then the number of electrons that are lost has to equal what was gained. Otherwise, you're losing things and that doesn't make sense in chemistry. Is that a question?
I was just wondering why it's like 2 electrons, because it's like adding 1 to the silver.
Because there are two silvers.
Yeah, good question. So in terms of the charge, it is just +1 to 0. But in order for the whole reaction to be balanced, right, that's why we have 2 of them. So good observation. Okay, let's look at Robert. So this was taking overall, split it into halves. Let's take 2 half reactions and put them into a full.
Oh,
Okay,
sounds like lots of fun.
for a smiley face with your table buddy, identify which one is the oxidation and which one's the reduction. Go.
Wait, Boom. They're just old ox. That one is.
How would that work?
Gabe, I have lots of copies. Do you want me just to look at?
Gain electrons.
No, it's, I mean, like literally, I have like copies of notes that nobody's used. So you can just combine with your other ones.
Yeah.
Since you're here, right?
Yeah.
I'm a genius. Taylor, for once, I think you
Same one back to
Yeah, no problem.
How does it feel?
Okay, if you said this, you can have a smiley face.
Hey, no.
Yes.
You can have a smiley face. You can have a smiley face.
Now, for the overall reaction, we're gonna combine the two together, but we've gotta make sure the electrons add up first before we do so. So in this case, aluminum is losing 3, zinc is gaining 2. What's a common multiple of 2 and 3?
6.
So I'm gonna times the top reaction all by 2. And this reaction all by 3.
He's not wrong.
Now when I write it in the overall, you just gotta keep them on the same side of the arrow they're already on. So everything on the left should stay on the left. So I'm gonna have 2 ALs plus 3 zinc ions plus 6 electrons. Turning into 2 aluminums.
I can hear that whole song. I'm not sure how, but I actually
Yeah. I only know that.
3 zincs and 6 electrons.
ALS.
Wait. Is, oh yeah.
It's ASL. That's what.
I know ALS. I feel like that's
Yes.
That's it. Trying to figure it out.
Questions on that?
Oh, do we have to write the charges?
Now for the net, the net reaction.
Yeah, that's it.
Okay, give me your focus
You just
here a little bit,
Googled it.
everybody.
You just
Back half the
Googled it.
room. We might need to social distance you more. Okay, the net reaction doesn't show the electrons. Because in a sense, they're like canceling out, kind of like before, because they're the same on both sides. So the net reaction is 2 solid aluminums with 3 zinc ions, changing into 2 aluminums, ions, and 3 solid zincs. Now, it's extremely important with precipitation and redox reactions that you don't lose charges. Because in chemistry, it's very different to have a solid thing versus the ion of it. Once again, for example, solid sodium, right? We saw that explode in water. Sodium ion is what we eat. Okay? They are
Yes.
very, very different. So if you don't like them differently, it means all sorts of different stuff.
Wait, so what if you ate solid sodium? Would you like explode?
Well, it probably wouldn't make it down your esophagus. 'cause
Yo, Taylor, $5 if you try it.
It would just explode on your tongue, probably, and your tongue.
Yeah,
That
yo,
would've
$5
hurt.
in one.
I don't think it would make it to your stomach.
Or you encase it.
What if you had it?
What if you encase it
Oh,
in
you
a
take it
pill?
as a
Oh.
So it dissolves in here.
Dissolves in the shell. And then it reacts.
That would be bad. That would be real bad. Especially because you don't just have water in your stomach.
Yeah, you got.
You have acid.
Would that work? It feels like a pill. And then it was dissolved to like shell or whatever.
Well, that's like why things are in pills, is because they don't dissolve in our mouths, but then the stomach acid can dissolve them.
Dude,
Right?
that would be so weird, just sitting around and all of a sudden,
Boom! People's like, oh,
there is the sodium.
I think you guys think you live in like a cartoon.
It kicked in.
I would not be opposed to living in a cartoon.
Okay. Any questions so far?
Are you aware that the circle,
Was I right on it?
well, I mean, it was like in the middle of
Okay.
it, so, you know, just to think about.
It is always. Okay, let me know if it gets to a bad spot.
All
But
right.
I'll try to write. If I write low, do you see
Yeah.
that?
Yeah.
Yeah,
Is there there? Okay.
Yeah.
Okay. Maybe I'll do the next practice problem lower. Okay, so now in the problems we've seen so far, it was fairly straightforward to see the movement of electrons because you had something that was solid turn into an ion. Other reactions are not as obvious. Sometimes the electrons are kind of hidden. So what we have what are known as oxidation states that help us understand and track the movement of electrons. Now, there are a lot of different oxidation states, just to give you an idea. And this image isn't the greatest up here. Okay, but these little beams up here are telling you all the different oxidation states it can be. Where top of it is 0, going forward is positive, going backward is negative. So cesium can be -1, 0, or +1. Right? Some of the ones over here can be a lot of different things. So the first thing you need to understand is the oxidation state is not the same as the charge we've been talking about. Because in terms of a charge, what charge does lithium have?
One.
+1, right? And it's always +1.
Taylor.
Okay? Or like bromine, what's the charge of bromine?
-1.
-1, right? It's always -1.
Falling behind.
In terms of oxidation states, bromine can be lots of different things. Now, sometimes it is connected, where its oxidation state is its charge, but you do need to understand they're different. That's actually one of the things with writing charges of why and once you don't have to do this, but if it helps, when we write the charge of a substance, you typically write this charge after the number. When you're talking about oxidation states, you write the charge in front of the number.
Oh my god. I'm a
Once again,
student.
that doesn't
Yeah, no,
matter.
that's like something that
This is gonna end me.
messed up.
But if it helps, if it doesn't help, forget what I just said.
Okay.
Okay?
Oh my gosh, I'm dead.
So, what we have is we have a series of rules that help us identify oxidation states. Okay? Now, majority of elements on the table don't have a rule, meaning it just comes down to a balance of the math. For the ones that do have a rule, they help us fill in the gaps. Okay? So, to kind of help us understand the rules, we're just going to go through that first practice problem at the same time. Because I find just reading you the rules right now, like, doesn't really make much sense, but it makes a lot more sense if we do it as we solve a problem. So, take a look at example 4.9a, and our objective here, okay, is my sunshine,
You're good. That's
I'm
for the
okay if I
right
start
of it.
here? Okay. So I'm just gonna write it down really quick.
Yo, Taylor, you're on point with these songs.
Okay, so our objective here is this.
I bet Matt's gonna play on this guitar.
We want to identify the oxidation state for sulfur in each of these different compounds. Okay? So, first off, what we do is if the periodic table gives only one oxidation state, we use that state. So the only ones that are always are group 1, group 2, and 4.
Okay, so something happened during class and we lost the video of these two practice problems. So let's walk through them this way. So we're assigning oxidation states for sulfur. Okay. Now, when we assign oxidation states, we start with by looking at the ones that have rules, which are designated on this table here. And then if it doesn't have a rule, then we just need to add up the oxidation states so that the compound either equals 0 or equals the charge, like here, if it has a charge, it needs to add up to that. So let's start by going through each one and focus on what has a rule and then balancing out the sulfur, because as you'll notice on this list here, sulfur doesn't have a designated rule for an oxidation number. So, okay, hydrogen does though, and it says hydrogen is usually +1, except in a metal or with a metal, then it would be -1. So in H2S, sulfur is a non-metal, so hydrogen would be +1, so I'm going to put +1 below it. Okay, now I'm going to get the total because there's 2 hydrogens, so both of them together gives it a +2, so in order to balance that out, the sulfur must be a -2 oxidation state. Okay? For the next one here, since sulfur is all by itself and it's not bonded to anything else, and that means it needs to add up to 0, it is just 0. Going to the next one, there is a rule for chlorine. It says chlorine is usually -1. So we're going to put -1 for chlorine. Same thing, get the total. -2, which means sulfur, is going to be a +2 oxidation state. Going to the next one, going once again to our rules here. So group 1 metals are always +1, so that is sodium. Okay, oxygen is usually -2. Okay, so now I'm going to do their totals to help me balance. So there's 2 sodium, so that's +2 total. There's 4 oxygen, so that's -8 total. So that means in order for it to balance out to be 0 altogether, sulfur must be a +6 oxidation state. Okay, and then our last one here, same thing. Oxygen is -2, 4 of them, so it's -8 altogether. Now it needs to add up to just -2, so sulfur in this case would be another +6. And try this next practice problem on your own. Pause the video, and then once you have your answers, press play to check them.
Yay!
Okay, they don't even understand the drama we just went through.
Dang it, Max!
Okay, you can do a
I'm gonna
closing
make the
song.
rainbow.
I did not know.
Okay, here we go, everybody. I have pressed. Last thing, and then you can work on some stuff. Okay, so we're gonna do oxidation numbers to track what's being lost and what's being gained. So going through our list of rules again, I always, so once again, look for any metals, don't have any. The next one I always look for is oxygen. Okay, in this case, oxygen's all by itself though, so
0.
So this would be 0, this is -2, this is -2. I just like to go through all of it. If you want to do it piece by piece, doesn't really matter. Okay, the next one that has a rule is hydrogen. Hydrogen is usually
+1.
+1. That would be +1. This would be +1.
My +1 looks like an H.
Okay, the only other ones that have rules are fluorine and chlorine, which aren't part of this, so now we just fill in the missing pieces.
Which is carbon.
Okay, so I'm going to do some totals in red. Okay, so hydrogen here would have a +4 for the total,
So
which
close.
means the total of carbon would need to be -4.
Well, -2.
But I have 2 of them,
Yeah, so.
so its individual state would be -2. Okay, alright, that's 0 coming over here, so the total here would be -4, which means carbon would have to be +4. And we're done.
Oh, let's go.
Yeah, we can go home now.
Well, not done.
Aw.
Sorry.
Yeah.
Now you're excited.
No,
Okay.
I like this class, don't get me wrong.
This is my favorite class.
I'm just tired.
We couldn't tell, Gavin.
What?
Okay, so carbon, I'm tracking my
Oh,
change.
yeah.
Carbon went from a -2 state to a +4 state, meaning it has been
Oxidized.
oxidized. Thanks, Taylor. Now, this is where you've got to make sure you don't track totals. Hydrogen is +1 here and still +1 there. It's like a
Nothing
spectator.
happened.
So it's not part of this.
Useless.
Okay?
It's a note there.
So oxygen changes from a 0 to a -2.
So it's reduced.
that's your answer.
No.
Is that carbon is being oxidized and oxygen is being reduced. Yeah, Harley.
I'm a little confused because oxygen gains 2 electrons, right?
Yes.
So why is it being reduced?
Because
Word.
oil rig.
The word reduction refers to the fact that its charge is going down. So that's, yeah, it's a little backwards filling the first stuff. Does that make sense? Yeah. So, good question.
Can I
Any other
just
questions?
buy
Isaac?
oil rig?
So would you just leave it like that and not be your answer, or do you have to put like something to the side saying like C is oxidized?
Yeah, if there was like a free response for your homework, I'm fine with that. You can just write it like that. If it was like a free response question, you would maybe want to like just put it into a sentence, right? Just saying, you know, carbon is being oxidized, oxygen is being reduced. But that one they might even accept because you can tell what's, if all the questions said like state what's being oxidized and what's being reduced, it shows it there, so. Any other questions? Okay, one more smiley face. Solve this one. Ready to go.
Yeah.
Dang, that's big.
Here we go. Okay, so we have oxygen, which is generated
Wait, how do we do it?
same thing.
No difference in.
Okay, and then all together that would be 14.
Zero, okay.
Negative 14. So because of
This
the
one's
2
a
minus,
zero.
each chromium is
There are a lot of zeros.
Wait,
Plus
those are all, that one's,
Okay,
this one and that one are the only ones that-
14. Oh boy. 14 has to equal 2 minus.
Wait,
Sorry,
sorry.
what? I couldn't hear you.
I'm
pretty slow.
That one is
Hydrogen,
6
wait,
plus
oxygen
6.
is only minus 2.
That's 0, bro.
Well, yeah, but
Slow.
they're all-
Oh, 0.
Whatever.
Wait.
They all have a charge. Like,
Yeah, if it has a charge and there's only one of it, does it still go to 0?
What do you think?
Well, no. But also, yeah.
Wait, but it doesn't make sense.
So if it's not bonded to anything else,
Oh, that's just
the
that.
oxidation state should be whatever
Oh,
it
that's
is.
just the
So if it has
charge, not
a
the
charge,
oxidation.
it's a charge. It was 0 before because it was a neutral field. So if you have lots of zeros, then rethink what you're doing.
Yeah. Oh, that's a 4.
Okay, so this would be.
what about like the number?
Wait, so it is like that?
In
Okay.
terms of, because keep in mind, oxidation states are based off individual atoms, so the number in front doesn't matter. If you were like tracking totals, then it would, but I good question.
That one's already balanced.
Okay, so then we have to find out oxygen.
Okay, so then this one,
Okay. So CR
Okay,
goes
wait,
to.
no, because we have to do this now.
Oh, yeah, we have to do the dragon.
So chromium
this one goes
is
down, so
reduced.
this one's a reduction.
Oxygen stays the
Wait,
same.
does that mean like multiple oxygens in one?
Hydrogen becomes
PRO.
oxidized. Nope, it becomes reduced.
Wait.
Yeah,
Hydrogen goes
but
from
the,
plus
well, the
one
O
to
part.
Well, then set your pencil down when you're done.
Never mind, we're good, we're good.
Is SN goes from plus 2 to plus 4, so that's oxidized.
Ox, red and ox.
So
And the ox.
The O doesn't.
Hand me the ox, is
The
that what you
ox
said?
board.
Wait, so
Oh,
the
okay.
CR is reduction, right?
AUX.
And then the oxygen doesn't change, it's just 2.
I think we got that right.
Yeah, I think,
Okay,
and then
they would.
The H doesn't change.
It's SM that changes.
Yeah, SN2 is,
You did.
it's an
Oh,
oxidation.
minus 2. Plus 2. Oh, we're popping up, Taylor.
Oh, actually,
We're
it's
popping up.
similar.
Oh!
Yes.
Yo, Taylor, we're onto something here.
Oh,
Let's see if we got it, let's see if we got it.
boom.
Let's go!
Yeah.
Dude, we suck that.
It's not even fair.
What in the world? Totally got that right.
So I was just.
Okay, so you should have,
Pop it on.
oh, sorry, keep working in your, don't look up if you're still working.
So they just start making videos in the middle of class. My teacher walked over and like, Taylor?
Nielsen. Look, he's so funny. We were just like that, and she's like, okay guys, try not to laugh. She gets up there and like, this is right, and just breaks out.
Well, the question was to identify what we got and what we reduced, so I guess if you got that, you're okay.
Yeah, no,
Just be careful with your
I'm
numbers
in
next
error.
time.
He used the wrong processor. How did you get there? No, I did
Any questions about oxidation reduction?
Let's go.
Yeah, that's a smiley face.
See, I think I went through an entire row of smiley faces today. No.
Yeah, I've gotten like 8
So
today.
it's
I got
all
7. I think I got
about
7
tracking
today.
the
Yeah, I've got 7.
individual numbers and if they change, the individual states.
That would be another.
So hydrogen is +1 here, and the individual state is still +1 there, so it's still gonna change.
You didn't do it?
Oh,
Does that make sense?
wait.
I did it.
I think you can still.
No,
Yeah,
it's kind of a little
we counted
best.
as 7 or 11.
But like the
so-
individual state of it is +1. That's a great question, Aaron, because I'd say that's like probably the most common mistake is people start tracking totals, and then all of a sudden you have like lots changing and stuff. Hey, tell me this really quick, everybody. What would you do if you solved a problem and you have 2 things being oxidized and nothing being reduced?
I would
You're
use
maxed
that
out.
screw with the
Because-
pole.
Yeah, try again, right? That can't happen. Yeah, Evan.
For the November smiley face challenge, can we add the smiley faces?
I'll add them on. I have a little stamp I'm gonna put on it for you.
Oh, I was literally gonna ask that.
The same question.
Yeah, that's kind of
That's
psycho.
Yes.
There's some guy at.
Okay, we have 11 minutes left of class to work. You can pick whatever on your chemistry to-do list, and you have lots on it, so pick something. Okay? Don't put anything away and don't work on anything else either until you're done or 1 minute before the bell. Okay? We got plenty of time to work.